speed is equivalent to what we know as a constant speed, or sometimes we say is a uniform speed. Okay, and the applied force is 12 Newton, and there's no air resistance. Okay, for the first part of the question, draw the forces acting on the object. Okay, this is what we call a free body diagram. The most common thing that you are looking for would be the weight of the object. It must be drawn from the center, which is the CG. CG will be covered in chapter 4 and chapter 5. Okay, so weight is always pointing down. Okay, we label it as W. Okay, and the formula for weight is M times G. Okay, mass is kg, which is 4 kg given in the question. G will be gravity, which is 10 Newton per kg, which is fixed for Earth. Okay, and the answer will be 40 Newton for the weight, which is pointing downwards from the CG. 12 Newton applied force is applied on the right side. Okay, so this is a 12 Newton force. Take note, it's drawn from the center of the object, which is 12 Newton. Okay, and common thing that we have is because the object is in contact with the floor, there would be friction. Okay, friction, remember, must be always drawn between the contact surface, so not any other place, so don't anyhow draw. The last one that we have is the action and reaction pair. Because the box is lying on the floor itself, the floor will apply an upward force onto the object itself. Okay, so please take note of this. Okay, so the floor will exert a force upwards onto the box, and we label it as reaction force. Okay, so this will be the answer for chapter 1, for question 1a. For 1b, what's acceleration of the box? Take note, the important fact that we have is steady speed. Okay, steady speed, this is the important fact. Okay, because steady speed gives us certain information. Okay, like I mentioned before, steady speed. Okay, another name for it would be constant, or what we call uniform speed. Okay, uniform speed, and this information will tell us that the acceleration of the object is actually 0. Okay, so the acceleration for the object will be 0 meter per second square, because it's based on the question, is it moving at constant speed or steady speed. Okay, so take note of this. Okay, this fact is one of the common tricks that we use in the question. How about part C now? Okay, what is the magnitude of the ground friction? Okay, so this question here, 1C further enforce that there is friction along the surfaces. Okay, so take note of this. Okay, so for the friction is on the horizontal surface. So horizontal surface, I will draw the forces again. Forces on the horizontal surface, okay, would be from the center, would be the force applied. Okay, which is 12 Newton. And that's a friction, okay, between the surface. Okay, so now you apply Newton's second law on the object, or Newton's law on the object. Okay, so F net is equal to ma. Okay, so based on question 1b, you know that A is actually 0. Okay, because it's steady speed. So you know that. So based on this information, you will know that the right side of the equation will be mass is 4 kg multiplied by 0. So the right hand side of the equation will become 0 automatically. So for left hand side, F net refer to the horizontal axis, the forces, sum of forces on the horizontal axis. Okay, so we take right as positive because the object is moving right. So F net will be F applied minus the friction. Okay, these two is the horizontal forces. So F net minus friction. So based on the question, F applied is actually 12 Newton. Okay. So this will be 12 Newton minus F equal to 0. Let's rearrange. You have F equal to 12 Newton. Okay. So this will be the answer for part C. The friction will be 12 Newton. students have to take note is that the question says the force applied now is 18 Newton. So which means the force applied now has increased to 18 Newton. Okay, but things to take note is that the friction still remain the same as 15 Newton. Okay, same as the previous question. And is it 15? Oh no, it's 12 Newton, sorry, my mistakes. Okay, so it will be 12 Newton. Okay, so it will be 12 Newton. It is still the same magnitude for friction because why? Because friction is dependent on the floor and the box itself. The box itself and the floor has not changed, so the friction is still 12 Newton. Okay, so what is the acceleration produced? Okay, same thing, we apply second law here, F net equal to ma. Okay, so what is the acceleration? So now F net is horizontal, so we take right as positive. Okay, sum of forces in the horizontal axis will be F applied minus friction equal to ma. M is 4 kg and A is what we need to find, which is the unknown. Okay, force applied now is 18 Newton. Friction still remain as 12. Okay, so now you solve for acceleration itself. So 18 minus 12 will be 6. So you will have what we call 6 divided by 4, which is 3 over 2, which will be 1.5 meter per second square. Okay, take note, your answer has to be 2 or 3 SFR in physics. Okay, so please take note, 2 or 3 SF, both are acceptable. Okay, things to take note from this question, I repeat again, is that the friction of the object remains the same, okay, even when the force applied has increased, because friction actually depends on the surface itself. Okay, so please take note of this. No, so now what happened to the last part? Higher speed reach. Okay, you must remember the question time is given is 5 minutes. So higher speed, you have acceleration, you have force. So the things that you are looking for, or the formula that you're looking for, should be your chapter 2 kinematics. Okay, why? The simple formula will be A equal to V minus U divided by delta T. Okay, acceleration, you have it in the previous part, which is 1.5. Based on the question is that you are supposed to find the higher speed, which is the final speed, okay, final velocity. The question is given that the initial speed is 0.1, so your U will be 0.1. Okay, so the time given is 5 seconds, so this will be a 5 seconds. So if you rearrange the equation, you rearrange the equations, you will have 1.5 multiplied by 5. Okay, this will be a simple math in action. So if you rearrange it, you will find that your V will be 7.6 meter per second. Okay, things to take note is 2 SF. Okay, 2 or 3 SF. Okay, so take note of this. Okay, so remember chapter 3 and chapter 4, chapter 2 and chapter 3, they are usually linked together, kinematics and dynamics. Okay, so I hope this will be easier for you.